The National Electrical Code, or NEC, specifies the maximum number of outlets permitted on general-purpose branch circuits and small appliance branch circuits. For a general-purpose branch circuit, the NEC specifies a maximum of 12 outlets are permitted. Within this limitation, there is a further restriction of no more than 6 outlets per yoke. The relevant section is NEC 210.11. C1. This means that if you have a single device box, sometimes referred to as a yoke, you cannot have more than 6 outlets connected to it. For small appliance branch circuits, the NEC specifies a maximum of 13 outlets. Similar to general-purpose circuits, small appliance circuits also have a limitation of no more than 6 outlets per yoke. This information can be found in NEC section 210.11. C2. It's important to adhere to these NEC guidelines to ensure electrical safety and prevent overloading of branch circuits, which can lead to overheating and potential fire hazards. Overloading a circuit can cause the circuit breaker to trip frequently, which is inconvenient and could indicate a potentially dangerous situation. By limiting the number of outlets on a branch circuit, the NEC aims to distribute the electrical load more evenly, reducing the risk of overloading. The term outlet in the NEC refers to a point in the wiring system at which current is taken to supply utilization equipment. This includes receptacles for plugging in appliances, as well as lighting fixtures and other permanently connected electrical devices. Understanding the difference between general-purpose and small appliance branch circuits is also crucial. General-purpose branch circuits are typically used for lighting and general receptacle outlets throughout a building. Small appliance branch circuits, on the other hand, are specifically dedicated to supplying power to small appliances in the kitchen, such as refrigerators, toasters, and microwaves. NEC Article 210 provides requirements for branch circuits. Section 210.11 covers the number and types of branch circuits required. The specific subsections 210.11. C1 and 210.11. C2 address the requirements for dwelling units. Firstly, 210.11. C1 talks about branch circuit requirements for general illumination and convenience receptacles. In addition to the previously mentioned limit of 12 outlets, these circuits must be rated at 15 amps or 20 amps. Secondly, 210.11. C2 covers the requirements for small appliance branch circuits. These circuits are specifically for receptacle outlets in the kitchen, pantry, dining area, and similar locations. They must be rated at 20 amps. Also, it is required to have at least 2 small appliance branch circuits to serve these areas. These circuits should have no other outlets. This is to avoid overloading the circuit with other devices. Thirdly, 210.11. C3 requires at least one 20-amp branch circuit for laundry. This is for the laundry area. This circuit should have no other outlets. Fourthly, 210.11. C4 requires at least one 20-amp branch circuit for the bathroom receptacle outlet. This is to ensure safety for the bathroom. The code goes over the maximum number of outlets on branch circuits and also dictates the minimum requirements of branch circuits that need to be installed in dwelling units. This also covers the number of small appliance circuits in dwelling units. Also of importance are the wire sizes and overcurrent protection for branch circuits. The most common branch circuits are 15 amp and 20 amp circuits. 14 American wire gauge copper wire is commonly used for 15 amp circuits. 12 American wire gauge copper wire is commonly used for 20 amp circuits. It is important to consult the NEC for conductor ampacity ratings. NEC Table 310.15. B16 provides allowable ampacities of insulated conductors rated up to and including 2000 volts. For example, a 14 American wire gauge copper conductor with type THHN insulation is rated for 15 amps at an ambient temperature of 30 degrees Celsius. A 12 American wire gauge copper conductor with type THHN insulation is rated for 20 amps at an ambient temperature of 30 degrees Celsius. It is important to ensure that the overcurrent protection device, such as a circuit breaker, is properly sized to protect the conductors. The overcurrent protection device should not exceed the ampacity of the conductor. This is to ensure that the circuit breaker trips before the conductor overheats and causes a fire. When installing electrical wiring, it is important to follow all applicable codes and standards. This will help ensure that the electrical system is safe and reliable. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to safely install and maintain electrical systems. There are also rules regarding voltage drop in branch circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause lights to dim and appliances to operate inefficiently. The NEC recommends that the voltage drop on a branch circuit should not exceed 3%. The total voltage drop on both the feeder and branch circuit should not exceed 5%. Voltage drop can be calculated using Ohm's law, which states that voltage is equal to current times resistance. To reduce voltage drop, you can use larger conductors or shorten the length of the circuit. Also related to circuits are the rules about arc fault circuit interrupters, or size. Size are devices that are designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur when there is damaged or deteriorated wiring. Size are required in many areas of the home, including bedrooms, living rooms, and hallways. The NEC requires a size to protect all 120 volts single-phase, 15 amp and 20 amp branch circuit supplying outlets or devices installed in dwelling units. The NEC also has requirements for ground fault circuit interrupters, or GFCIs. GFCIs are devices that are designed to protect against electrical shock. A ground fault occurs when electricity flows through an unintended path to ground. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The NEC requires GFCIs to protect all 120 volts, single-phase, 15 amp and 20 amp receptacles installed in dwelling units in locations such as bathrooms, garages, and outdoor locations. It's also important to understand the different types of receptacles. The most common type of receptacle is the duplex receptacle, which has 2 outlets. There are also single receptacles, which have only 1 outlet. Receptacles are available in different amperage ratings, such as 15 amp and 20 amp. When replacing a receptacle, it is important to use the same amperage rating as the original receptacle. Using a receptacle with a lower amperage rating can overload the circuit. Tamper-resistant receptacles are also required in dwelling units. Tamper-resistant receptacles have internal shutters that prevent children from inserting objects into the slots. The NEC requires tamper-resistant receptacles to be installed in all areas of dwelling units. Another important aspect of branch circuit wiring is proper grounding. Grounding is the process of connecting electrical equipment to the earth. Grounding helps to protect against electrical shock and prevents the buildup of static electricity. All branch circuits must be grounded according to the NEC. The grounding conductor is typically a bare or green insulated wire that is connected to the equipment grounding terminal. The equipment grounding terminal is connected to the metal enclosure of the electrical equipment. Surge protection is also an important consideration for branch circuits. Surge protection devices, or SPDs, protect electrical equipment from voltage surges. A voltage surge is a sudden increase in voltage that can damage electronic equipment. SPD are available in different types and sizes. They can be installed at the service entrance or at individual branch circuits. The NEC requires SPD to be installed in dwelling units. They can provide protection from transient overvoltages. When wiring branch circuits, it is important to use the correct wiring methods. The NEC specifies the types of wiring methods that are permitted for different applications. Common wiring methods include non-metallic sheath cable, also known as Romex, and electrical metallic tubing, also known as EMT. Non-metallic sheath cable is commonly used for residential wiring. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Electrical metallic tubing is commonly used for commercial and industrial wiring. It consists of metal tubing that is used to protect the conductors. When running wiring through walls and ceilings, it is important to follow the NEC guidelines for supporting and securing the wiring. The wiring should be supported at regular intervals to prevent it from sagging. The wiring should also be secured to the building structure to prevent it from moving. Also consider the use of junction boxes. Junction boxes are used to enclose wire splices and connections. They provide a safe and convenient way to make electrical connections. Junction boxes must be accessible and should not be covered with insulation. When making wire connections, it is important to use the correct wire connectors. Wire connectors are used to join two or more wires together. There are different types of wire connectors available, such as wire nuts and crimp connectors. It is important to use the correct type of wire connector for the application. Wire nuts are commonly used for splicing wires in junction boxes. Crimp connectors are commonly used for terminating wires to devices. Proper labeling is also an important part of branch circuit wiring. All branch circuits should be labeled to indicate their purpose. This will help to identify the correct circuit when troubleshooting or making repairs. The label should be clear and easy to read. They should also be permanently attached to the electrical panel. Also consider the proper use of extension cords. Extension cords should only be used for temporary purposes. They should not be used as a substitute for permanent wiring. Extension cords should be properly sized for the load that they are carrying. They should also be in good condition and free from damage. When using extension cords, it is important to avoid overloading them. Overloading an extension cord can cause it to overheat and start a fire. The NEC also provides guidelines for the installation of lighting fixtures on branch circuits. Lighting fixtures should be properly supported and secured. They should also be installed in accordance with the manufacturer's instructions. When installing recessed lighting fixtures, it is important to ensure that they are properly rated for the insulation that is being used. Recessed lighting fixtures can generate a lot of heat. They can also cause a fire if they are not properly installed. Also, when working with electrical wiring, it is important to always disconnect the power before starting any work. This will help to prevent electrical shock. You can disconnect the power by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before disconnecting the power, it is important to test the circuit to make sure that it is not energized. You can use a voltage tester to test the circuit. If the voltage tester indicates that the circuit is energized, do not proceed with the work. Call a qualified electrician to disconnect the power. When working with electricity, it is important to wear appropriate personal protective equipment, or PPE. PPE includes safety glasses, rubber gloves, and insulated tools. Safety glasses will protect your eyes from flying debris. Rubber gloves will protect you from electrical shock. Insulated tools will help to prevent electrical shock if you come into contact with energized wiring. The NEC is updated every 3 years. It is important to stay up to date on the latest changes to the code. This will help to ensure that your electrical work is safe and compliant with the code. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. You can also find information about the NEC on the NFPA website. In summary, remember that the NEC specifies a maximum of 12 outlets on general-purpose branch circuits, with no more than 6 per yoke. For small appliance branch circuits, the limit is 13 outlets, also with a maximum of 6 per yoke. These limitations are crucial for electrical safety.